Alright, so now we're going to talk about similar solids. This is really just an extension of Unit 5, which was similar triangles, okay? Except now we're in 3-dimension. Our scale factor is defined exactly the same way. It's the ratio of any of the corresponding parts, the matching parts. For example, the small one here is 4 and the small one here is 6. So those two correspond. I can put those in a fraction to give my scale factor. Okay, so ratio just means a fraction. Okay, that's what ratio means. Okay, so that's really a review from Unit 1. That's not something new. I would put that in my calculator and hit math fraction. So 4 divided by 6, math fraction. I always want to simplify scale factors. So I get 2 to 3. Now that would have worked if I took, the two long ones, 10 and 15, 10 divided by 15, math fraction. That's how we defined a scale factor, those corresponding parts. Things are proportional when they're similar. So as soon as I see similar, I want to be thinking fractions, ratios, and sometimes my problem solving will involve a proportion. Okay, a proportion was like if I had two fractions, something over something equals something over something. We did that a lot in Unit 5. Okay, so here when I simplify this, I got 2 to 3. Now in Unit 5, we also talked about this right here. We discovered that this says a perimeter that has to be something flat. So let's pick the front faces here. So perimeter is distance around the outside. So this is 6, 9 plus 6 plus 9, and this was 4 plus 6 plus 4 plus 6. So the perimeters that I'm going to get here, on the small one, I get a perimeter of, let me do this with a different pen here, since my ugly handwriting is all over this, that's going to be 20. And the perimeter on my larger, the front face here, has a perimeter of 30. Now when I put those in a fraction, the ratio of the perimeters of the front are going to be 20 over 30. And when I put that using my calculator, you might already recognize what this is going to be. When I simplify that, I'm going to get 2/3 again. So we actually discovered this in Unit 5. This is all review so far. So I didn't talk about it at length in Unit 5, but the reason why these have the same ratio is because these are both one-dimensional measurements. Okay, they're both measured with a ruler. So anything that I can measure with a ruler. Okay, so for example, I wanted to measure this side right here, that length. I use a ruler. So anything that I measure with a ruler, perimeter is also a ruler. I would just have to turn it every time I get to a corner there. But that's measured in one dimension, just a length. Okay, so that's why those two are always going to be equivalent, and that's used in problem solving. What we're going to discover now is we're going to look at areas and volumes. Now here I wrote ratio of surface areas, and if you were in my class right now, I would send you off to find some areas for me, but I'll do that part for you. But this is going to apply whether you do area of base, just a regular area, surface area, lateral area, and area is all measured the same way. Remember, the area would be how many squares. So I'm just going to do this with one of it. Okay, so this is 4 by 6. So area is measured in squares. Now let's do like the area of the front side here is 4 times 6. And the area of the front face here, if I broke that into 6 squares this way, 9 this way, so I'm going to have 6 times 9. The area of the front face there is going to be 54. Alright, so I could do this with the areas, then I might send another group of students to do the surface area of this one and the surface area of the larger prism, and we'll find 248 on this and 558 on this. So again, whichever one you're choosing to set up, you could do the area of the base, or they asked for surface area, so I'm going to do that. So surface area was 248 and 558. So again, ratio just means put it in a fraction. So that's all I'm doing right now. So if I put this in, I've now moved to area, which is measured in squares, 2-dimension. It's not going to be the same. But whether I'm doing surface area, which I got 4/9 here, or I did the regular areas, the areas of the front, 24 divided by 54, what you will notice here is that's still an area. It's still measured in squares. That one is going to give you the same. So all your areas are going to have the same ratio. And if you look at your 1 dimension, this squared, 2 squared is 4, 3 squared is 9. So if I want to move from 1 dimension to 2 dimension, I didn't need to actually calculate the areas. This will always be true. I'm going to square things to go to 2 dimension. So why is this 2 dimension? 2-dimensional. Let me show you a picture because they're measured with squares. Remember, I counted up all the squares here. I used a formula, but that's how you could find it. So why is that 2 dimensions? Because when you measure with a square, you have a length and a width. You have 2 dimensions. So that's what I mean by 2 dimension. Okay, now what do you think is going to happen with volumes? Again, if you were in my class, I would send some of you to find this volume and the rest of you to find this volume so that we could answer this question. Okay, you might already be thinking about the fact that volume is measured in 3 dimensions. So what do you think will happen? So 240 over 810. It's not going to be the same as the area ones, okay? It's not going to be the same as perimeters because that's 1 dimension, that's 2 dimension, but now this is 3 dimension. So you can use your calculator to discover this. Math fraction. It's 8 to 27. But if you think about where those numbers come from, again, volume is 3-dimensional. Now why is it 3-dimensional? Because I measure it with a cube. Now, how do I measure a cube? Or, why is this 3 dimensions, I should say? Because it has a length, a width, and a height. So that's 3 of these. Okay, this is 2 of these. And I'm pointing that out because ultimately what we just discovered here is that if this is my 1 dimension, if I was given a 1-dimension ratio, okay, now what is 1 dimension? Let's make sure we know that. My 1 dimension is my scale factor and my ratio of perimeters. Those are 1 dimension. So if I'm given a 1-dimension ratio here, and I wanted to, you'll see when I do problem solving, I do it this way. I write what dimension I'm given, and I write what dimension I'm moving to. So if I wanted to move up, whether I'm going to 2-dimension or 3-dimension, I'm going to take my 1 dimension and I'm going to use an exponent. So let's look at the volume, for example. If I wanted to move from 1 to 3-dimension, I'm going to take 3 of my 1 dimension. So it's going to be this times this times this, which means I'm cubing it. And you can enter this on your calculator. If you use your alpha y equals, the fraction key will give it back to you as a fraction, but you need parentheses if you're not using your fraction key. And then this little guy right here will do an exponent other than 2, so to the 3rd power. And if I just, hit enter right now, it's going to give me a decimal, so I'm going to do math fraction. If you get the decimal, change it to a fraction. So that's how I could get my 3-dimensional ratio. Okay, that's how I got that. So again, if I was going 1 to 2, I was taking the 1 dimension and squaring it. If I'm going 1 to 3, I'm cubing it. Sometimes you're going to have to go backwards So then you have to just think, what's the opposite of an exponent? Okay, it's going to be a root. So the inverse operation of an exponent is a root. I should just say opposite of exponent is a root. So what I mean by that is that if I'm going up, I'm going to be using an exponent. And if I'm going backwards, so let's say I'm given my 3-dimension, or let's do one like this, my 2-dimension. Let's say I was given my 2-dimension. Okay, so any of the areas is 2-dimensional. So if I'm given my 2-dimension, because you'll see my problem solving, I'm going to ask, what is that? That's 2-dimension. So how do I get back down if I was asked for, say, the scale factor? How do I get back down to 1? Well, the opposite, to get from 1 to 2, I'm going to square that. So the opposite is the root. So I'm going to square root. And because the square root opens that bar, you don't really need parentheses on this because the whole thing is underneath. Now I want to make that a fraction. So math, fraction, do 3. Okay, so that's a root is going to go down. Okay.